Everywhere is somehow touched by investment casting. Investment cast parts are used in everything, from aerospace to zippers and everything in between. If you eat, chances are your food was processed by machinery with investment cast parts. If you travel, your airplane or other transport probably contained investment cast parts. If you've been to a doctor, you have likely seen surgical tools which were investment cast. You may even have an investment cast artificial bone. If you go to the dentist, you probably carry an investment casting in your mouth. If you play golf, your clubs could be investment cast. And your military is one of the greatest consumers of investment castings, both in terms of ordnance and aerospace applications. While investment casting has many modern uses, the basic process has been used for more than 6,000 years to produce sculptures, jewelry, and ornaments. But the development of investment casting as a production method began roughly in the middle of the 20th century. The industry has grown steadily since that time, and today enjoys annual sales in the United States alone of more than $3 billion. Investment casting is the only metalworking process to produce net cast parts. A net cast part is one which is usable as is, without expensive and time-consuming machining, welding, and multiple assembly. Investment casting can and frequently does do all these things. Investment casting saves time, money, and materials. Investment cast parts are designed to minimize the cost of producing close tolerance for finer finish parts. Machining is frequently eliminated. Multiple part assembly can also be eliminated because investment casting combines the best of several manufacturing processes. The initial tooling cost for investment casting is inexpensive, and there is little or no waste of expensive alloys. Investment casting is the designer's dream. It offers infinite alloy choices, new design parameters, thin walls, better finishes, internal cores, and more. Restrictions are few. Investment castings are regularly produced in weights from a fraction of an ounce to several hundred pounds. Some fine arts castings can weigh several tons. The majority of parts, however, are in the relatively small category. Now, let's follow the investment casting process through some typical foundries. To begin the process, wax patterns are made by injecting molten wax into an aluminum die to make an exact replica of the part. Wax injection presses make larger, high volume, and more complex parts feasible. Laser technology and plastic patterns are an attractive alternative for some investment casting applications. In the next step of the process, the patterns are assembled with great care on a post or sprue, which is in turn fastened to a pouring cup. Attention to detail is critical if the molten metal is to find its way into each detail of the mold. Assembly room temperature and humidity are carefully controlled to guarantee that the pattern retains dimensional stability. Complex runner systems are required in many cases to provide the gating or metal flow channels in the mold. The completed assembly is then processed to produce a ceramic shell mold. This is accomplished in several stages. First, the wax assembly is dipped into a cleaning or etch bath and then pre-wet before it is dipped into the first coating of slurry. This is a critical step in the process, for the operator must produce an almost flawless coating upon which to build the shell. The assembly is carefully examined, and any bubbles in the coating are burst with an airstream. The wet assembly is then inserted into either a fluidized sand bed or a rainfall sander, where the sand particles adhere to the wet surface. Care must be taken to make sure that every detail of the assembly has been properly coated. The assembly is then placed on a rack to be dried under carefully controlled conditions. Additional coats of progressively coarser grades of material are then applied to the assembly. Finally, the desired shell thickness is achieved. The shell production process lends itself very well to automation. Robots have been developed to carry out the shell build-up sequences. Such equipment is programmed to follow the normal hand-dipping procedures, to reduce labor costs, and to remove variables of a manual operation. If we take a typical assembly and section it, we can see how the ceramic coating faithfully follows the contours of the wax patterns. And when the wax is melted out, a precise cavity remains into which metal may be poured. The next step in the casting process is to remove the wax and fill the mold with hot metal. The removal of the wax is usually a two-step process. First, the major portion of the wax is removed in a steam autoclave. Next, the shell is placed into an oven where the last remaining wax is burned out and the ceramic shell fired. The metal, which has been melted in an induction furnace, is poured into a transfer ladle. It is then poured into the preheated shells and allowed to cool. Different types and sizes of ladles are used, depending upon the size of the part to be cast and the alloy being poured. In some cases, the shells are placed into fluidized sand beds for pouring. Light alloys are generally handled quite differently. When the metal has reached the right temperature, substantially lower than in the case of ferrous metals, it is usually placed in a special chamber and poured in a vacuum. The last stage of the process is to remove the shell from the newly formed cast. After the molten metal is cooled, the ceramic shell is removed either by vibratory methods or with high-pressure water jets. In some cases, the remaining shell material is removed in a blasting cabinet, with the resulting casting assembly looking exactly like the wax assembly previously seen. The individual castings are removed from the assembly through the use of high-speed cutoff wheels and then cleaned in a salt bath. The gates are removed by grinding, and final cleaning is done in a variety of finishing machines. A minimum amount of hand finishing is required when parts are properly cast. Heat treatments are often used to enhance physical properties, and other options frequently improve the already fine finishes of the investment casting. Some parts require careful gauging for possible distortion, and representative samples of every run are carefully checked by quality assurance for strict conformance to specifications. In summary, the investment casting begins with a wax pattern made by using a die. The pattern is mounted with others on a tree or assembly. Next, the assembly is given a fine pre-coat of stucco, followed by several coarser coats of stucco. The wax is removed in a steam autoclave and the ceramic shell fired. The molten metal is then poured into the shell by a transfer ladle. After cooling, the ceramic shell is removed by vibratory methods, and the finished casting appears looking exactly like the original wax pattern. Investment castings may be large or very small, intricate or relatively simple. They are often net cast, precise and completely finished and ready to use as cast. Hundreds of companies representing dozens of industries have replaced thousands of parts by investment casting and saved millions of dollars. What about you? If you're currently using machining, forging, die casting, permanent mold casting, stamping, powder metallurgy, roll forming, or weldments, investment casting can combine the benefits of all these. There may be a better way, the Netcast way. For detailed information on case histories, applications, design, tooling, alloy selection, quality assurance, and how to buy, contact the Investment Casting Institute in Dallas, Texas, or an Investment Casting Institute member.